Welcome to Quantum Realms Explained, your guide to the mysteries of the universe. Today, we dive into one of the most foundational and perplexing concepts in quantum mechanics, the Copenhagen Interpretation. This is a topic that can challenge our everyday understanding of reality, but it's crucial for grasping how the quantum world works. Have you ever wondered if something could be in two places at once? Or if observing something actually changes it? The quantum world is far stranger than fiction, and the Copenhagen Interpretation attempts to make sense of its bizarre rules. Developed primarily by Niels Bohr and Werner Heisenberg, the Copenhagen Interpretation emerged in the late 1920s as a framework for understanding quantum phenomena. It's not just a theory, it's a philosophical stance on what quantum mechanics actually means. At its heart, the Copenhagen Interpretation rests on a few key ideas: wave-particle duality, superposition, and the profound role of observation. First, wave-particle duality. Quantum objects like electrons and photons don't behave strictly as particles or strictly as waves. Depending on how you observe them, they can exhibit properties of both. Then there's superposition. Before measurement, a quantum particle exists in a superposition of all its possible states simultaneously. It's like a blurred image where all possibilities are present at once. This brings us to the most controversial and fascinating aspect: the role of observation. In the Copenhagen Interpretation, observation is not a passive act. When we observe a quantum system, its wave function, which describes all its possible states, collapses. This means the particle chooses one definite state out of all the superposed possibilities. So the act of measurement fundamentally changes the system, forcing it to reveal a specific reality. Before observation, we can only talk about probabilities. This leads to the crucial role of probability. Quantum mechanics, under the Copenhagen Interpretation, doesn't predict exact outcomes for individual events. Instead, it provides probabilities for various possible outcomes. You can predict the statistical behavior of many particles, but not the precise behavior of one. The famous Schrödinger's cat thought experiment perfectly illustrates superposition and observation. Before the box is opened, the cat is considered both alive and dead simultaneously, its fate linked to a quantum event. Only by observing does its state become definite. The Copenhagen Interpretation has profound implications for our understanding of reality, and it hasn't been without its critics. Many find the idea that reality isn't definite until observed deeply unsettling. Despite philosophical debates, the Copenhagen Interpretation became the standard view because it works. As the saying goes, shut up and calculate. It provides accurate predictions for experiments, even if the underlying reality remains elusive. Of course, it's not the only interpretation. Others, like the Many Worlds Interpretation, propose different ways to reconcile quantum strangeness, but Copenhagen remains the most widely taught and used. The Copenhagen Interpretation challenges our intuition about reality, forcing us to rethink concepts like observation, probability, and what it means for something to exist. It teaches us that at the quantum level, particles exist as probabilities, becoming definite only when measured, and that observation itself is an active participant in shaping reality. The quantum world is an ongoing mystery, full of wonder and profound implications for physics and philosophy. Understanding the Copenhagen Interpretation is a vital step into this fascinating realm.